So today we're going to learn how to solve radical equations. So we've got 4 examples we're going to look at, so you're going to have 4 different videos to watch. Now, just like in solving quadratic equations, you had to isolate the x squared. In all of these examples, before you can do anything, you have to isolate the square root. Okay, so let's take a look. First example. So I have 3 plus the square root of 2x minus 3 is equal to 8. So I first need to get the square root by itself. So I've got this 3 that's in the way. So it's 3 plus, so to move the 3 to the other side, I'm going to subtract the 3 from the 8. So then now I have the square root of 2x minus 3 is equal to 5. So now I have the square root by itself, and I need to get rid of the square root. So to undo a square root, you have to square both sides. So now the square root's gone. I have 2x minus 3 is equal to 25. So now I have a linear equation. I'm going to add the 3 to the 25, leaving me with 2x is equal to 28. Then I want to divide both sides by 2. And I have x is equal to 14. Now, just like with any equation, you always want to go back and check. Make sure that that solution works. So I'm going to take my value of 14 and I'm going to plug it into the original equation. So inside my parentheses, I'm going to sub in the 14. So then I have 3 plus the square root of 2 times 14 is 28. 28 minus 3 is 25. Square root of 25 is 5. 3 plus 5 is 8. Ignore the background noise, that's just my voice. So it checks out. It's a true statement. So our value of x is 14. Okay, so I'm going to go ahead and get into the second example in the same video. Let's hope I can keep it under 10 minutes. So example number 2. So I have the square root of x plus 7 minus 5 is equal to x. Okay, so again, just like we said before, we want to isolate the radical. So always isolate the square root. So to do that, I'm going to add the 5 to both sides. And I have the square root of x plus 7 is equal to x plus 5. So then next, to undo a square root, I've got to square both sides. So now my square root is gone, and I have x plus 7 is equal to x plus 5 quantity squared. Now, if you remember in the last unit, you are not allowed to distribute that square to the x and to the 5, okay? You have to expand this out because this is a quadratic function, and if you graph that, you'll know you'll remember that that's a double root. So if I expand it out, and I'm going to write it twice, then I don't care if you use the box or if you use the full. It gives me x squared, 5x and 5x, so 10x plus 25. If you use the box, you know that you're going to have the middle quantity. So the x squared here, 5x, 5x, and 25. So that's going to be equal to x plus 7 on the other side. And now I have a quadratic equation that I'm trying to solve. So again, you see why the other unit was a prerequisite for this one. So now we've got to set everything equal to 0. So I'm going to move the x over here and the 7 over here. So 0 is equal to x squared plus 9x plus 18. And so now I have this quadratic equation that I have to solve. I've got several methods now of solving. I can solve by graphing. I can solve by factoring if I have rational roots. Or I can solve using completing the square or the quadratic formula. So I'm going to solve by factoring because my roots are rational. So factors of 18. Sorry guys, that's my boys in the background. Now you can see what I go home with. Factors of 18 that add to 9. So 6 times 3. So x plus 3. And x plus 6 are my factors. And so then now you set each factor equal to 0. And so x is equal to -3, or x is equal to -6. So this next step's really important. Okay, so this one appears to have 2 solutions, but just like we did a second ago, we have to check our solutions. So when I go back and I plug in to check, we're going to find out if both of these solutions work or not. So now I'm going to check. So I'm going to go back to my original equation. And I'm first going to check -3. So I'm going to plug -3 into the equation. And I'm going to see if this is a true statement. So -3 plus 7 is 4. The square root of 4 is 2. 2 take away 5 is -3. So our -3 works. So now we want to check the other solution. So now we're going to check and see if the solution -6 works. So again, I'm going to go back. To my original, and I'm going to plug in -6 into my x. And we're going to simplify. So -6 plus 7 is 1. The square root of 1 is 1. 1 minus 5 is -4. So negative 4 is not equal to negative 6. So x is equal to negative 6 is not a solution. So when this happens, this is called an extraneous solution. So the solution negative 6, because it was a false statement when I plugged it back in and it didn't work, it's called an extraneous solution. So the second video that you're going to watch is going to define what extraneous solution is, and then we've got 2 more examples that we're going to look at. Now, when we learn about graphing radical equations, we're going to understand about the extraneous solutions and why this happens.